Good day, friends. Today I named the talk as "And Miles to Go Before I Sleep." This is a line from the poem Stopping by the Woods in a Snowy Evening by Robert Frost. We studied it in our school. I like this line, miles to go before I sleep. So, this is a talk on the random walk, simple random walk. We have x axis, we have y axis. I'm starting from 0, 0. I'm starting from 0, 0. And I'm counting number of moves and number of returns to 0, 0. So I'm moving with 1/4 probability. I'm moving 1 unit rightwards in x-axis. With 1/4 probability, I'm moving 1 unit leftwards in x-axis. With probability 1/4, I'm moving 1 unit upwards in y-axis, and with probability 1/4, I'm moving 1 unit downward in y-axis. So I'm doing a random walk, a simple random walk on the plane, and I'm counting the number of returns. So it starts from 0, 0, and it does a random walk, and when it comes back to 0, 0, the number of returns increases. And I'm trying to see what is average return time, which is nothing but number of moves by number of return. So we know that one-dimensional and two-dimensional simple random walks are recurrent. That is, with probability 1, you are coming back to origin. But when it goes to higher dimensions, 3 dimensions, 4 dimensions, etc., the probability of eventual return decreases. But although one-dimensional and two-dimensional simple random walks are recurrent, the probability that it comes back to where it started from is 1, but the expected value of the time of return, expected value of return time is infinity. So one doesn't know when it is going to come back. So I'm trying to sort of conceive the model, sort of have an idea about the model while doing a simple random walk on plane. So I can move one step at a time. It has from 0, 0, it has gone to 0, 1, and maximum it has gone in absolute value is 1 along x-axis, and along y-axis the maximum it went, the absolute value is 0. So let me do some random walk. So it has come back to origin 1. So number of returns is 1. Let me see if I can get another return. Now it's moving only on y-axis. There is another return. It came back to 0, 0. Number of returns is 2. What about the third one? And it's memoryless. I mean, the past, the random walk that's happening from a point doesn't depend on the history. So every move is a fresh start for a random walk. So it will take time to come back to 0, 0, it seems. Eventually, with probability 1, since it's a two-dimensional random walk with probability 1, it will come back to origin, but the expected time of return is infinite. Let me move 10 steps. Number of returns is not increasing. It has gone to minus 10. Maximum it went along x-axis in absolute value is 30. Maximum it went along y-axis is 20. I am moving 10 steps at a time. That is, I'm looping over the move by one step 10 times. Nothing new. Let me try 100. No, number of returns is not increasing. Let me do 1,000. 100 moves are over. 100 moves are over. 100 moves are over. 400 moves are over. 800, 900, 1,000. So after 1,000 plus moves, maximum I went along x-axis in absolute value is 39. It can be in positive side or also in negative side of x-axis. Maximum along y-axis, the point moved is 57 in absolute value. Number of returns is 2 and average time of return is 941. But this doesn't make any sense. It will go on increasing because number of returns are becoming less and less. But we know with probability 1 it will come back to origin. One can go to 10,000, but it will take time. So I won't click the 10,000 button. I can do one thing. I can freeze. I can pull down the y-axis value to 0 and can do a one-dimensional random walk along x-axis. So let me see what happens. See, when I put the y-axis value to 0, so many returns have happened. 28. But if I freeze both of them to 0, then it doesn't move. It remains at 0. So it's a sort of display of two-dimensional and one-dimensional random walk. I'm trying to have the idea about the fact that although it is coming back to origin in finite time with probability 1 for one dimension and two dimensional, the expected value is infinite. Expected value of the return time is infinite. Thank you.